So we always have two coordinates. That's what we have studied so far, x and y. And यहाँ पर z है out there, physics में but x and y. That's what we have studied in 10, right? And whatever point there is, suppose the point is over here, then let's say this point has coordinates 20, 10. So what this means is, when you say x coordinate is 20 and y coordinate is 10, x coordinate 20, it means that this distance is 20. Is that clear?
Yes.
The x coordinate is distance from y axis and y coordinate is 10, that means this distance is 10. Understood?
Yes.
Okay, you remember this part?
Yes.
Right? So x always runs horizontal in the standard form. Okay, right side is positive x and left side is negative x. Alright, similarly upwards is positive y and downwards is negative y. This is what we normally have. Okay. There is something called distance formula. Do you remember distance formula? Do you remember Pythagoras theorem?
Yes.
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 Something distance formula आवडेल ते. Both are same thing.
Yes.
Great. Also, what distance formula says is that if you want to find out distance between one point here, let's say A, 20, 10, and suppose there is some other point, let's say B over here. For example, 50, 30. Right? Let's say 50, 5. Okay, and you want to find the distance between them, between A and D. So you join them like this by a straight line, correct?
Yes.
The length of that straight line is the distance between them. Fine. But if you would watch this carefully, you can actually make a right angle triangle like this. Did you understand what I have drawn?
Yes.
Right? Here there is right angle. So it will look like this. A, B, and suppose here is C. So if I want to find this AB, then what I should do is, I should find this AC, I should find BC, and then I should use Pythagoras theorem. Right? That will give me AB. Now, have a look at this. If this is 20, and here x coordinate is 50, from here to here, it will be 50. Did you understand?
Yes.
Sure? Then how much will be BC?
30.
This is 20, that's 50, so this will be 30.
30.
So actually, if you realize how you are getting 30, it's like this. Correct or not?
Yes.
આ જ હતું તમારી બુકમાં x2 minus okay or not?
Yes.
Just like that. Let's go to y, vertical. So for example, this y coordinate is 10. What that means is from here to here is 10. And this is 5. So from here to here is 5. So this remaining will be 10 minus 5. Is that clear?
Yes.
From here to here 10. From here to here 5. So this remaining portion A to C must be 10 minus 5. That is 5. So this is what you used to write as y2 minus y1. And now this distance by Pythagoras theorem is AB squared equal to AC squared plus BC
square.
Right? So BC square is nothing but x2 minus x1 whole square and AC square is nothing but y2 minus y1. And square root of the distance formula and it is called distance formula. Understood?
Yes.
So frankly, it's just Pythagoras theorem, but you are using coordinates to express everything. So suppose you do it here, then it's going to be 30 squared plus 5, and then you take square root by end. Okay. So very quickly, I want you to understand that distance between any 2 points A, B, for example, is always going to be x2 minus x1 whole square plus y2 minus y1 whole square under a root. Got it?
Yes.
Okay. So can you quickly find the distance between A 1, 1 and B 7, 2? What would be the answer? Give the answer in form of square root. Okay, that's it. That's what we want. What will be distance between A and B? Done. Raise your hand when you are done. Okay. What's your answer will be? Root 37 is what she said. Who agrees? Who disagrees? What's your answer, Vishwa? Root 40, root 40. Jennifer? Can't hear you. Root minus 37. When you square the whole term, you'll always get it positive, right? So, if I were to do it, I'd call this x1, y1, x2, y2, okay? So, x2 minus x1. Even if you write x1 minus x2, it's okay, huh? Don't worry about that. Square term will same as because when you square, the negative will always become positive, so it's fine. Right? So, what do we get? 7 minus 1? 6 squared, correct?
Yes.
Plus 2 minus 1, 1 squared. So, my answer is going to be root of 36 plus 1, that is root of 37. Okay?
Yes.
Understood this?
Yes.
Good done. Well done. Alright? How do you distance formula?
Yes.
That's it. We might need this distance formula at some point or the other. Okay? Now, just before we end up this little discussion, I want to ask you that as you move, suppose this point is 2010, okay, that point A here. As we move, let's say in vertical direction like this, which coordinate will change and which coordinate will not change? As we go from A upwards like this, which coordinate will change? Y coordinate will change. Is that clear?
Yes.
But X coordinate will not change. Because X coordinate depends on the horizontal. X coordinate indicates the horizontal distance. So if you just go up like this vertical on this figure, diagram, then only Y coordinate will change. It will increase or decrease? Increase. Right? From 10 it will become 11, 12, 13 and so on. Got it?
Yes.
So when you move vertical, only the Y coordinate. When you move horizontal, only the X coordinate changes. આપણે અહીંયાથી જાય. Chapter 3. We were talking about motion on
Straight line.
horizontal. Then we were saying that the position is X. So only X coordinate was changing. We are not even talking about Y coordinate because it was not changing. It was of no use for us. Similarly, when something moves on a vertical line, then only Y coordinate will change. Did you get that?
Yes.
Sure.
Yes.
Fine. So I think that's enough of the introduction. બીજું બહુ જરૂર નહીં પડે about coordinate geometry. So hopefully you have written the distance formula and everything. No, the camera is on, right? So on to vectors. So what are vectors? Vectors are something that have a magnitude, of course, and also have a direction. Vectors are something that have magnitude and a direction. But that's not it. Okay? And also follow. So what's a vector? It is something that has a magnitude, has a direction, and also follows the triangle law of addition. Also follows the triangle law of addition. Only then it's called a vector. Otherwise it's not called a vector. Okay. Then looking at what is triangle law of addition. Of course we are going to cover it very soon. Right? So just having a magnitude and a direction does not make it a vector. Let me be clear about that. Current is one quantity. For example, there are a few more, but current is the simplest one to understand. When you were in 10th standard, I'm sure you have studied that there is a wire and current is flowing in this direction. Have you indicated things like that?
Yes.
So is current a vector? No. Current has a magnitude. Like for example, you might say that current is 1 ampere. Remember ampere or not?
Yes.
Okay, current is 1 ampere. It's the magnitude. And what's the direction? Right side. Okay. It has a magnitude, yes. It has a direction, yes. But is current a vector? No, because it does not follow triangle law of addition. What is this triangle law of addition? We'll get to it eventually. Okay, step by step. So current is an example of something that has a magnitude, has a direction, but is still not a vector. What are examples of vectors? There are so many. Position is a vector, displacement is a vector, velocity is a vector, acceleration is a vector, average velocity is a vector, force is a vector, momentum is a vector, torque is a vector. Alright? There are so many. Temperature, mass, volume, not a vector. Understood? These are something that are not vectors. Scalar. Right? Okay, we are going to separate them. What are scalars? You know this from 9. It's optional. If you want to write, you write it. Otherwise, it's okay. What are scalars? Scalars are those things that have only magnitude. That's what you were taught in 9th standard.
Yes.
Right? But basically, the more appropriate meaning is don't follow triangle law of addition. Don't follow triangle law of addition. Then that is what is called a scalar. But in detail, okay, the difference of these two is clear.
Yes.
Right? Very really. Now we will start with position first. Okay, then we will go on to displacement, and when we will reach displacement explanation, and that time you will understand what is triangle law of addition. So let's understand about position. Suppose we are, this is my favorite example. Let's say we are part of a government spying agency, okay, a part of anti-terrorist organization. Alright? And we are sitting in our helicopter or drone and we are observing or we are watching, keeping an eye on a terrorist. Okay? And this is what we are seeing from the top. Here is origin. Origin is where the terrorist has a hideout or a house where the terrorist lives. Understood?
Yes.
Okay. And at some point of time, we notice that the terrorist is here. Alright? Let's say this is Osama bin Laden. Okay. Alright? And we are keeping an eye on him. He's wrong date, of course. But anyway. Right? You can put the terrorist of your choice here. No problem. Anyway. So, or you could say, this is Virappat. You know who was Virappat?
Yes.
Yes, no? You know? He was a very infamous person who used to smuggle sandalwood, okay, from the forests of Karnataka and Kerala, right? Okay, and like he was really a big problem for many years for the Indian government. Anyway, coming back to physics. So let's say here is a terrorist, right, whom we are observing. So you find that at some point of time the terrorist is at a distance of 200 meters from the house. 200 meters from the house. Okay or not okay?
Yes.
But if you would report, let's say you all are my superiors and I am going to report, right? Target is at 200 meters from the house. The obvious question will be,
Which direction?
I hope it has come naturally to you. 200 meters पर क्या है? आप हवा में उड़े? You get what I'm saying?
Yes.
So 200 meter in some particular direction. Also, when we say 200 meters, do you realize it's the distance from the origin? In chapter 3, I think I mentioned that position is always measured as a distance from the origin. Do you remember?
Yes.
So 200 meters is the distance from the origin. Okay, so you have a frame of reference.
Yes.
Okay, so here is the origin, here is that person, that's the position, 200 meters. But that's not enough information. We definitely need a
Direction.
Did you understand?
Yes.
So is position a scalar or a vector? Position
Vector.
is a
Vector.
First, position is a vector.
Vector.
Now the symbol of position is not x anymore. X to x coordinate માટે આપણે લખતા હતા. The symbol of position is not x. પતી ગયું જૂના symbol પતી ગયા. હવે ભૂલી જવાનું. Okay, I know it's very hard. એક chapter માં માંડ આવ્યું પછી હવે ભૂલી ગયું. Don't worry, it will not happen often. બસ આ એક જ વાત છે. So R is the symbol of position, but because position is a vector, on top of it we should indicate the arrow. Okay?
Yes.
Okay, team no uniform તો પહેરવો જ પડે. Is that clear? So position is a vector. Did you understand?
Yes.
Now why is it a vector? Again, because we need a magnitude. 200 meter is the magnitude, but we also need to specify the direction. So it's like somewhere between north and east. But that's a very vague description. એવું ન ચાલે. Somewhere between north and east. તો મિસાલ ક્યાં પડે? You get what I'm saying?
Yes.
So generally directions are specified by angles. So for example, you could say 60 degree north of east. How much would be the position? 200 meter and 60 degree north of east. Do you understand the meaning of this?
Yes.
60 degree north of east. So first of all you look towards east and then you turn 60 degree. In which direction? Towards north. Now, did you understand?
Yes.
60 degree north of east. The same thing of course can be written like this also. 30 degree east of north. Same meaning ek hota hai. Did you understand?
Yes.
Okay, it's fine if you use any one of them. You don't need to use both. Got it?
Yes.
This is how we specify direction. Of course, there are many more ways. We are going to learn them all. Right? This is just the first one. Did you understand?
Yes.
The position is a vector. Right? We specified the magnitude, that's 200 meter, and also the direction by using some angle. Got it?
Yes.
Now, if this person is there, first of all, walks to this point. Now, chalo, example to समझे क्या? Let's take another case. So suppose in some other case, again we are spying on terrorist. Here is the origin or the reference. So the terrorist starts from the house. Listen to this chapter. The terrorist starts from the house. Okay, moves 300 or rather just 30 meter towards east and then 40 meter towards north. Okay, that's what the terrorist does. Maybe terrorist is on the morning walk. Alright? Okay. You never know. Okay, so can you imagine how he is going to move?
Yes, sir.
Yes or no?
Yes.
આ ચાર તો આવડે જ ને?
Yes.
ઓકે કન્ફ્યુઝન થી કાંઈ કોઈ દિવસ કે નોર્થ કઈ બાજુ આવે ને મને ખબર છે એસએસ તો તમને ખબર so here મેપ ના જ માર્ક મળતા હતા so 30 meter your secret has been spilled okay મને ખબર છે મારે એસએસ માટે બધા માટે તો મને નહીં આવડતું okay so 30 meter east. So from here to here, correct?
Yes.
Okay, let's say this is O, origin, and suppose this is A. Then from O to A, and then what?
40
From A
meter
to
towards
B.
the north.
Let's say 40 meter north. So this is 30 meter, and that is 40 meter. Did you understand this?
Yes.
Yours?
Yes.
That's physics. Find distance traveled by the terrorist. एकदम easy है. Find distance traveled by the terrorist. How much?
50.
Raise your hand. for the answer. Find distance traveled by the terrorist. एकदम easy question. Distance traveled means path length. Correct or not? Path length. क्या थी क्या जाए from O to A and then from A to B. How much is the path? वो अगला question पूछ लेता मैं. क्या बात है? Okay, Millie. Louder. 70 kg. 70 meter. He says 70 meter.
Yes. Yes.
Yes. Who says yes? Who says no? કોઈ નહીં. Are you sure? આની પહેલા જ્યારે આવતી હોય ત્યારે ખબર ને બધું ખોટું નીકળે. યાદ તો છે ને? When everyone agrees to the same thing, we often find that it is wrong. Simple. Not this type. This is correct. 70 meter is the path length. Understood?
Yes.
Sure?
Yes.
Now, next, we are going to understand what is the displacement. Okay. So, just let me make you recollect what I have told you already about displacement in chapter 3, and it's also true here. Displacement only depends on initial point and final point. Does not depend on path. Second, magnitude of displacement is shortest distance between the initial and the final point. That's the 2 points which we are talking about. Correct or not?
Yes.
So magnitude of displacement is the shortest distance between the 2 points, initial and final. So who can tell me what is the magnitude of displacement? Raise your hand. Magnitude of displacement. Raise your hand. Shortest distance between initial and final point. Yes, mantra. OB. So it would be OB, correct. How much would that be? Now, 50 meter. How do you know? Are you the terrorist? नहीं. मजाक करो जो, don't take it serious. How 50 meter long? Louder.
Auto B that's the
Go to B ચાલે છે, આમ ચાલે? આમ ચાલે. Magnitude of displacement is the shortest distance between
Initial and final.
Yes, Himakshi? 40 meters. Why? Initial. Now there was a 40 meter distance. Shortest distance. Why?
Because of the Pythagoras theorem, what is it would be 90 or 21.
This is eastwards and then that is northward. Correct or not?
Yes.
Everyone gets that? So
Yes.
here the angle is going to be
90
degree. Alright?
Yes.
If they have to love, you know the value. So you should have expressed it. Sit down everyone. Is it clear what's going on?
Yes.
30 meter this way, 40 meter upward, that is toward north. But what did I tell you? Displacement, magnitude of displacement is the shortest distance between initial point and final point. So I hope you realize this is the shortest distance between O and B. Correct or not?
Yes.
This is not shortest. Agreed? The shortest distance between O and B is always a straight line. Is it fine?
Yes.
Okay. How much is this? Hypotenuse is another.
Yes.
Okay. So how much would be that hypotenuse? Under root 30 square plus 40 square. That is nothing but 50. Got it?
Yes.
Alright?
Yes.
Now if I would ask you one more thing. Can you tell me the direction of displacement? You see, Displacement is from this point to this point. Agreed? From initial point to the final point. Correct or not?
Yes.
So displacement is in which direction? Like again, remember, displacement only depends on where it starts and where it stops. That's it. With initial and final. You don't have to see it goes here and here. Does not depend on path. Clear or not?
Yes.
Okay.
Yes.
So the displacement is from O to B. Do you agree? The
Yes.
displacement is from O to B. Did you get that?
Yes.
I'm in this direction. So what's the angle of that displacement from O to B? Angle sir. Yes, love.
60.
Yes, sir. Do you have proof? Say proof. Yes, sir.
Not too easy.
ये तो आ केस मानते हैं यार फिक्स है पर नहीं मान सकते this was 200 meters 60 degree north of it this is a different case okay
53 degree.
very good 53 degree ક્યાંથી આવ્યું સવારે શીખવાડ્યું તો યુઝ માં આવી ગયું અત્યારથી do you remember sit down let's say this angle is theta do you see a triangle
Yes.
okay do you see 4 and 3 and 5 here I mean 50 correct or not
Yes.
acha so હવે શું થાય what is sin theta according to this triangle 40 by 50 yes or no
Yes.
that means
4 by 5.
sin theta is 4 by 5 for which angle is sin theta 4 by 5 for theta equal to 53 degrees yes or no
Yes.
clear or not clear everyone theta equal to 53 degrees so if you want to mention the direction of displacement you could say this is 53 degree north of E. So this is a vector again I hope you are understanding what I'm saying displacement is a vector it has a magnitude it also has a
Direction.
is it fine
Yes.
clear
Yes, sir.
I want trigonometry no use how very good okay so be ready whenever you want to find angle trigonometry તરત જ યાદ આવશે sin tan cos કંઈક કરો so you'll be able to get okay understood 53 degree or not
Yes.
right okay probably you are still worried about અરે આવું આપણને આવડી જશે ખબર પડી જશે કે અહીંયા થીટા આવી જાય તો લઈ લેવાનું but you will get used to it really not that tough triangles માં ટેવ પડી જશે ધીરે ધીરે okay now displacement is a vector of course so it will have its own symbol own formula as well but path length this is path length d is the symbol of path length do you remember
Yes.
path length is a scalar quantity
Scalar.
so we have to say what's the direction of the distance traveled or what's the direction of path length no direction because some of the path was covered towards east and then some of the path was covered towards north a vector must have only one direction vector should not have 2 or 3 different directions did you understand
Yes.
sure
Yes.
path length scalar just like I mentioned earlier in chapter 3 but displacement is a what is displacement a scalar or a vector
Vector.
a vector so here we have found the magnitude of displacement 50 meter and we have also found the direction of displacement that is 53 degree north of it that is the there is shifts or moves displaces in which direction 53 degrees right north of it okay now let's write a proper formula for displacement acha chapter 3 ની formula આવડે છે displacement
Yes.
કોને આવડે raise your hand who remembers the formula of displacement from chapter 3 okay કેમ બાકી બધા ભૂલી જાવ છો હા yes manan
Except minus except.
very good displacement is delta x which is equal to xx minus x that was in chapter 3 because we were dealing with x coordinate now do you remember the definition of displacement What's the definition of displacement?
Change
Change in position of an object.
object.
And change in position always means final position minus
Initial.
position. Correct? So, displacement change is always represented by delta. Do you remember?
Yes.
Change means delta. Correct or not?
Yes.
So, this is the symbol of displacement. Delta R vector. Uniform बराबर पेरो जो है टोपी बुलाई न जो है. Is that clear?
Yes.
Without that, the meaning will change completely. Got it? Delta R vector is equal to, what should I tell? Final position. In chapter 3 we are using X. RF vector because position is a vector. RF vector minus RF. This is the new formula, new and improved version. Okay. Displacement is a vector, so delta R vector is equal to RF vector minus RI vector. Has the definition changed? No. Check. Only the way of writing it has changed. Okay. Now, let's just talk about a couple of more cases or examples for displacement. Can you read it?
Yes.
Okay. Now, how do you draw a displacement vector? It's actually very easy. I'm just writing it in words first of all, then I'll explain. Displacement vector is drawn as an arrow from initial position to final position. That's it. Ekdam simple. Displacement vector will always be drawn as an arrow from initial position to final position. See, here is origin again, spying on the terrorist. Suppose the terrorist starts from here, which is 10,0 meter. Okay, everything is in meter only. So 10,0. From here, the terrorist moves to, let's say, 10,10, and then moves to this point, which is 15,5 meter, which is 15,5, right, from here to here. So let's say this is A, here is B, and here is C. So we start observing here, so this is the initial point, and we stop observing here, so that is the final. Okay, so which point is initial? A, 10,0. A is initial. And which point is final?
C.
C, that is 15,5. Okay. So the displacement vector of this one, all throughout A to C, would be drawn from initial position to the final position. That is from A to C. I am displacement. So this is the displacement vector. Did you understand what I have drawn?
Yes.
Okay or not okay? Alright?
Yes, sir.
Okay, so from A to C. Now, I am sure all of you have that diagram that we had drawn earlier before this, the 30-40 one. Do you have it?
Yes.
Yes?
Yes.
So, I'll just redraw that diagram roughly. It was like this and like this, correct or not? Here it was 30 meter and this point was O, A and B. Now, a very simple thing. Do you realize that you can divide this journey from going from O to B in two parts? Correct or not?
Yes.
Yes or no?
Yes.
You can divide this in two parts. Which two parts?
O
O to A and then A to B. Correct?
Yes.
O to A to B. So suppose we are just talking about O to A. Then that's part 1. Right? First part. Agreed?
Yes.
And A to B, second part. Correct or not?
Yes.
So can you tell me, listen to this carefully, can you tell me what's the displacement in the first part only? What's the displacement in the first part? Look at the diagram in your notebook or look at the diagram here. I do it. What is the displacement in the first part? 30
meter.
Who says 30 meter? Okay. That is only the magnitude. Because displacement is a vector, isn't it? So vector must have magnitude and also direction. So 30 meter is magnitude. I agree with you, absolutely. 30 meter is the magnitude. But what's the direction of that displacement? What's the direction of this first displacement from O to A?
30 meters.
East.
Yes.
Sure?
Yes.
On the map, that direction is east. Correct or not? Look at it in your notebook. Hopefully you have drawn it, you'll be able to see it. So when I write it like this, displacement is 30 meter towards east. 30 meter is magnitude. And from O to A, that is towards the right side means east. Agreed?
Yes.
Now, what's the displacement in the second part?
40 meter.
40 meter. Okay. Alright? 40 meter north?
Yes.
Clear?
Yes.
Then, what is the total displacement? Total displacement means what from O to B? Yes or no?
Yes.
What is the total displacement from O to B?
50 degree.
What is it?
50
meter.
degree.
50 meter is the magnitude. Correct or not?
Yes.
Sure?
Yes.
Absolutely?
Yes.
Okay. And direction is
Not
completely different. 53 degree north of
east.
Are you noticing something a little odd?
Yes.
Did you see something strange?
Yes.
કંઈક બધું normal જ લાગે છે. What was the displacement in first part? In magnitude it was 30 meter.
30 meter.
In second part in magnitude it was 40 meter. But total 70 but so 50 આવે. This is something is a little strange here. 70 આવું નહોતું થયું. Displacement in first part 30, displacement in magnitude of course, second part 40, but total 50. Is 30 plus 40 equal to 50?
No.
No થાય ને? Sure?
Yes.
Okay?
Yes.
Let's take another example. Suppose instead of going that way, the trains would have moved as follows. Let's say first of all, a new case of the first case. First part, 40 meter east. Okay, from here to here. Let's say from O to P. And then the trains would have moved 50 meter west. 50 meter west. So anything
Yes.
from P to Q. So this is from O to P and this is from P to Q. Right? So how much is the total displacement? How do you find how do you find the displacement? Read the sentence at the top. How do you find the displacement? From initial position to final position, you draw an arrow. Okay.
Yes.
In this diagram, which is initial position?
O.
Which is final position?
Q.
Q. Clear or not clear?
Yes.
O is initial, Q is
Final.
So draw karo. O to Q. How આવશે ને?
Yes.
This one is the displacement vector. Correct or not?
Yes.
Okay. So how much is the magnitude of that displacement vector?
Minus 10.
Magnitude can be negative.
10.
10 meter. Yes or no?
Yes. Yes.
10 is not clear. Geometry the job. From here to here 40. Then from P to Q 50. So how much is O to Q?
10.
10 is right?
Yes.
Then okay, so total displacement. Total displacement is 10 meter. And in which direction?
Left.
Left. West. Yes or no?
Yes.
Sure.
Yes.
Left side is west, of course. North, upper east, west, and south. So 10 meter towards the west. Okay, एक बात तो didn't you add the displacement? Total कोने के वैसे? What is meaning of total? Addition, yes or no?
Yes.
Correct or not correct?
Yes.
And so is it really total or not total? It is total. Suppose, let's say, in 1 hour, you could write 5 pages. Then in 1 more hour, you could write 7 pages in another notebook. So how many pages did you write? Total. 11 no? So 4 ne 7 बोला कि 5 ne 7? 12. Is it fine?
Yes.
So when we say total number of pages, then you would go all the way from initial to final. So 12. So here also what we are really finding is actually the total displacement. There is no doubt about it. It is actually the total displacement. But total means addition, yes or no?
Yes.
But so add करिए तो एक weird type. The thing is, you are not adding 30 plus 40, 70, and here it's even horrible. 40 plus 50. Instead of adding, it's like subtracting, isn't it?
Yes.
So, do you realize that it's nothing but the directions to play in? Yes or no?
Yes.
It's nothing but the directions to play. I can give you one more simple example. Suppose instead of 40 and 50, this was 30 and 40. So, here 30, 40. Here 30, 40. So, our answer 10 meter west away. Yes or no?
Yes.
Why? Because this would be 30 and this would be 40. This is 30, this 40, this 30, 40. But because directions have changed, that's why addition is also different. You can
Yes, sir.
I'll repeat what I said. What is the displacement magnitude? 30, 40, east, north. Here, east, and west.
Yes, sir.
And the total displacement is different. Numbers change, sir? What did change between the two cases?
Direction.
And the result is completely
Different.
This is the vector-like behavior. This is the vector-like behavior. How important is this letter and this letter? I hope you understand what I am saying.
Yes.
बराबर है? And notably you करना है को तो 50 to 10 से क्यों? Direction एक एक वाला बजा. Clear or not clear?
Yes.
So when we are dealing with vectors and we want to add vectors, vectors don't add like numbers. સૌથી ખરાબ વાત વેક્ટર ની અને આમ જો તો સૌથી સારી. So can 40 plus 40 be 0 in vectors? Yes. Yes. Suppose this was 40 meter east and then 40 meter west. So
0.
total displacement 0. So can you add the numbers in vectors? No. Should you add magnitude directly? No, never. It's always going to be disastrous. Right? 40 plus 40 0 થાય now. 80 not 30. Just like that here 30 plus 40 is not 70. It turns out to be 50 when you add the displacement. Did you understand?
Yes.
So be careful with it. Right? When you want to add vectors, you have to
Direction.
take a look at direction. If you don't take a look at directions, then everything will go wrong. Okay, कोई केस में subtract ऐसा है, as you can see over there. 40 plus 40 gives you 0. Over here, if both of these are 40, 0 meter in no direction. Okay. Now, so how to add displacements? When you try to add displacements, you will always get a triangle. Have a look. Yo. First part displacement, O to A. Second part displacement,
A to B.
where is the total displacement?
O to B.
Let's draw them. આમાં draw કરવાનું ને ઉપરના sentence વાંચો.
Yes.
From initial point.
Final.
Okay. Do you see a triangle?
Yes.
That's the triangle law of addition. Anything that is a vector will always have this kind of weird property. Okay, add करवा जाओ ने, then you have to look at directions. If you have to look at directions when you are adding them, then that quantity must be a vector. If you don't have to look at directions when you are adding, then that quantity must be a
Scalar. Yes.
But what exactly is the triangle law of addition? That either we'll see today or we'll see next time, depending on how much time we have. Okay, and we don't have enough. Okay, right? So I hope you are seeing the triangle that is formed. એટલે જેને છે ને triangle law of addition. I will make you write the steps properly and we'll discuss it in full detail the next time. Alright, done.